This video is going to just be a sample problem working with circles and the algebraic definition of a circle. So what if we have 3 points, A, B, and C, and we want to find the equation of a circle given those 3 points that we know are going to be on the circle. So that is the given information, that these points lie within a circle, so that we can use the algebraic form of a circle here, and we can substitute each one of those points in to get an equation of h, k, and r that describe this circle. And then the whole point is we have the points, but we don't know what the position of the center of the circle is, or hk, and we don't know what the radius is. So we can algebraically solve for that using this method here. So I have here A, I plugged in the point 0, 0 into the equation, and we get this relation in terms of h, k, and r. And then similarly here with B, I would substitute the point 6, 0 into this equation, and then we FOIL out each term to get this this relationship, and then C has this relationship. And we can use the techniques of algebra. This is also kind of a introductory problem to a linear algebra, a topic in linear algebra, definitely. So let's take let's take C first, and I'm going to subtract A from C. So I have 64 minus 16k plus k squared plus h squared is equal to r squared. But I know k squared plus h squared is equal to r squared. So if I subtract k squared plus h squared from this side and r squared, or I could also see it like this. I'll substitute k squared plus h squared in for that r squared. And then we can see that these will subtract themselves out on each side of that equation, and I'll get 64 minus 16k is equal to 0. Or in other words, k is equal to 4. So this was actually pretty simple because I had the origin point already included in this circle, so it gives me this easy form to work with, k squared plus h squared. It's easy to cancel it out on each one of these. So I could do the exact same thing with B to find what h is. So I'll just do that real quick. K squared plus 36 minus 12h plus h squared. And instead of r, I'll just write k squared plus h squared. And then we'll subtract those out from each side of the equation, and I'll have 36 minus 12h is equal to 0, or h is equal to 3. So I have k is equal to 4 and h is equal to 3, and then I can just use this. I can just use a now to find out what r is. In other words, I know a was k squared plus h squared is equal to r squared, so 4 squared plus 3 squared is going to be equal to r squared, or r is equal to 5. Because I know this will be the 3 sides of a right triangle, 3, 4, 5 right triangle. Or 16 plus 9 is 25, and the square root of 25 is 5. So then I have k, r, and h. And then I can just take these values, substitute them back into the general form of a circle, and we have the equation of a circle that fits these 3 points. And this is not the most complicated form of this problem. It would be more complicated if I didn't have the origin point and I didn't have any zeros here and here, but we could still solve that. And maybe I'll do another problem later when I talk about linear algebra. I'll come back to this and we'll do a more complicated form of this and how that's solved algebraically.